Welcome back to Young Money. We're about to meet the co-founders of CRSP Design. Now, they've come up with a highly innovative toolkit for young children, and in this case myself included, because it teaches us the basics of electronics and something that I've recently learned called mechatronics. I'm not going to try explain it, but the guys will do. So I am joined by Nthato, Moagi, as well as Yoshlyn, Naidoo, and they're going to be taking me through what we have here. Guys, I just want to jump right in. This really looks exciting, but before I do that, what does CRSP Design do, and what is this product that you guys have brought to market?
So CRSP Design is a company that we've created to basically create inventions and designs that will make social impact, you know, in the country, in Africa, and probably the rest of the world. So what we've done with the low-cost educational robotics toy is create a little kit that kids are able to use in previously disadvantaged schools and environments to actually learn robotics and learn how to program and code from scratch in the classroom.
So, Yoshlyn, explain the big words that I used at the beginning as well. So, I'm hearing educational robotics, but when you were educating me earlier, you also spoke about mechatronics. So what are we talking about?
So, mechatronics is just basically the fusion of the disciplines of mechanical and electronics. So, robotics is basically a field of mechatronics. And basically what we want to do is expose younger kids to these STEM principles, so that they don't feel intimidated when they actually have to choose a career later on, you know.
Right. Yeah. So we're looking at what is the most appropriate grade for to start playing with these?
So we've actually chosen to aim this at grade 4 to 9.
Okay.
So that's very important because we feel like a lot of these STEM-based awareness campaigns are based around grade 10 to 12, but that's too late. You're supposed to get the kids early on, you know, spark that interest while they're still young enough, but they're also a bit old enough to understand how to use electronics. So grade 4 is that perfect line.
Right, so this is me now going back to grade 4. What's in these black boxes? Because I'm seeing on the one hand we've got names like switch, light, we've got a dial, we've got a battery, we've got a motor, and we've got a buzzer. So in essence, what am I holding in my hands?
Basically you're holding what you would call in engineering discrete components, but for kids obviously we would just call them modules, okay? So you can plug in these modules to create a circuit, okay?
Right.
And when you become more developed, you can actually then plug them into a control module that we will develop and actually start programming program these things.
Baby steps, baby steps. Let's go back to grade 4.
Yeah,
okay. So I'm going to build, I'm going to try and build a light. So, so this is the final, this is the light, right? Yeah. So if I'm looking at this, I'm like, okay, what do I need?
You need a battery.
I need a battery because I need power. And I probably want a switch so I can switch off on my light. And so it kind of works like Lego pieces, right?
Exactly.
So you find the side that fits, okay? It looks like it's a fit. So I've got my battery and my switch, and I'm gonna now try and connect my light. Okay.
So that's also a light.
Oh, this is also a light.
Yeah.
Okay, let's do the simple light. So let's put this light on. So there you have it. So I've done that, and now let's see if it works. Ta-da! So it definitely does work, but the learning is what happens here, right?
Exactly.
So tell me what's going on here, and what am I learning?
Okay. So basically, you've got a battery module. It tells you you've got a 9-volt battery. Okay. This is the description that you would see of a switch in what you would learn in electronics. You would draw the circuit diagram. So that's the representation of a switch. That's the representation of the light. So you can correlate your line drawing that you would study normally in the classroom with the worksheets with the actual practical experience, thus giving you a more insightful understanding of what's going on.
You see, maybe if I had done this when I was in high school, I wouldn't have done so badly at science. So I'm going to try one more, because this one says buzzer, so I really want to get the audio feel around it. So I'm going to connect that. Am I connecting the right side? Oh yeah, okay, maybe it's about...
Can roll?
Okay, so the switch does work, and again, if I turn it around, it's very clear about how those components fit together.
Exactly.
Now, this is really fantastic, and what you said, Nthato, right at the beginning, is that you're aiming this at low cost for disadvantaged schools. So let's talk pricing models. How does this compare with, say, a standard science toolkit that you would find in your average private school?
Yeah. So in your average private school, what they normally default to is the Lego Mindstorms kit, and that goes like for sale for around 4,500 for a kit.
Okay.
So I think initially with our aim, when we designed this, back when it was still just a thesis at the University of Wits, we were looking at the price point of 1,000 Rand and nothing more than that, because that's that sweet spot where like the schools are actually able to afford it, and price per head is way lower than what the
And
Lego
how many
kit.
of these would you find in a typically well-resourced school? And how many of these would you need in a low-cost school?
I think the major thing is in a private school, you'd find a lot more of these because they've understood the importance of actually having hands-on STEM education.
Sure.
Teaching kids how to code, because that's why you have your Bill Gates and your Mark Zuckerbergs. They started doing this when they were still young. So with the private schooling, they've understood that this is very important and critical for that. Whereas in your underprivileged schools, they think just teach the kid the concept, they learn it, they cram it, and that's it. But they actually need to apply it and put their hands on it.
So, Yoshlyn, one of the other things I'm seeing is that, I mean, this is almost like the basis of where you start, right? So this is my grade 4 level, but then you begin to advance. And what I'm seeing there on the screen is almost like this is what programming or coding would look like.
Sure,
So talk to me about what you guys are building here and how you're bringing, back to Nthato's earlier point, social impact by getting more young people to code.
So, of course, I think I would just bring your attention to, this is one of the earliest prototypes that we've ever built. Okay, and it's basically a wired car that Nthato actually found a kid playing with in Soweto where he grew up. And we actually used the concept. This is not as refined as when we got to the modules, but the plan is to get kids to actually build from scratch, using imagination, using modules, robotics, and to control the robotics, then there's the programming element that comes into play. And maybe Nthato can explain what
are we seeing on the screen there?
So what you're seeing there on the screen is basically a program that will just tell the distance between something, and it'll just change the lights that you had. So if you had that light module that you had right there, and you actually had another sensor module, you could get feedback from the sensor and you tell this light to turn on or not. You could think about it almost as a PDC, parking distance controller in your car.
So you could actually build one of these models with PDC
PDC functionality, and the kids can actually do this themselves. And we just wanted to prove that this shouldn't be expensive. I think, especially when you see it here on a wired car, now you can actually see that if a kid had anything better than this, they'll still be able to use it.
But we're still in prototype
Exactly,
mode, right?
yes.
So what does the end product eventually look like, Yoshlyn? What are you working towards?
So basically, we want to actually mass produce this so that we can get it accessible to as many kids as possible. Okay. So we're in the process of conducting our industrial design. So we're busy designing our components, both the enclosures as well as the internal electronics. For example, this would be how a PCB for the battery module would look.
Your battery module in there.
That's how it would look. Okay, we also want to go for the transparent aesthetic so that the kids can actually see what's in the box and it's not just a black box anymore.
You can actually see the wiring and
you can see the circuitry. We will design the PCBs and the tracks so that they will be able to understand how the circuit works. And then you would see that we also designed lesson plans, okay? So this is classroom activities. And that will tie into the curriculum of the schools so that we're not trying to disrupt the way kids are taught. We're trying to actually just bring in the infrastructure. Yes, enhance is right.
Sure, so I'm so excited. I feel like I'm in grade 4 again, but I want to go back. I mean, how do you guys even come to building this company and come up with these ideas? I heard that the initial idea came from a thesis. That was who was writing the thesis, who was stealing the other one's ideas, what was happening?
Okay, so basically for me it comes from my childhood. So I used to play with a lot of Lego, but my mom was a factory worker who couldn't really support my love for Lego and robotics as a child, you know. So I think at some point the dream was crushed. And then I found myself doing my 3rd year at Wits studying aeronautical engineering, and I could actually design and develop all of those things that I needed as a child from scratch, you know. And then I was like, wow, let me actually check what's available on the market, and I found out there was nothing affordable enough for for the basic African child, you know, for the basic kid from the previously disadvantaged background, underprivileged school. And that's when I chased this as a thesis for my final year and got an A for it, and I moved on and worked at Denel Dynamics.
Right.
That's where I met Yoshlyn there.
Yeah.
So
Okay.
I think while I was working on this, he fell in love with the idea as well, and he was like, you know what, dude, I'm joining
So you got
Let's do
Yoshlyn
this."
out of his job, in essence.
Yoshlyn is an engineering manager designing missiles and drones on a daily basis and satellites
Yeah.
at Denel Dynamics, but he's chosen to join me so we can do this.
So
for
obviously,
every kid
coming
out
from the high-tech environment, when I heard the idea, I thought it was awesome because it's actually so simple to
Yeah.
design, and the fact that this type of product is not out there and accessible yet is actually quite sad.
It's criminal.
What do you guys need to happen for this to go to market?
So I think what we needed was funding. That was last year, but the SAB Foundation and the support we got from the JCSE, so that's the Hack Josie people,
Yes.
that was amazing. And we just started this in April, if you think about it, started commercializing this. And within less than a year, we have our funding that we need, and that's why now we're just focusing on refining our design.
Final question, you spoke about the existence for CRSP Designs being about social impact.
Yeah.
If you could put it in a couple of words, what are you changing in terms of society as we know it through this product?
I think the biggest change we're making is access. To
Exactly.
give every single child out there access, you're giving them the ability to be able to be anything they want to be. And us coming from an engineering or technology background, seeing all those young people doing amazing things overseas, we know any other African child can do that. But they just need you to spark that knowledge in them, you know, spark that interest. And that's why for us, this is very, like, this should start that new movement
Right.
where more and more kids are able to see beyond just a wired car. They'll actually see a robot.
So there you have it. It's about access and making sure that the South African and the African child have equal access to high quality education. I've spent the afternoon with a fantastic duo from CRSP Design, and they've come up with this amazing toy robotics kit that they are in the process of building. It's been absolutely phenomenal talking to them. Remember that if you want the Young Money crew to come to you, all you need to do is just follow me on Twitter. It's that simple. It's at The Real Mozi or at CNBC Africa. Don't forget our hashtag is Young Money 410. Nthato and Yoshlyn. And Nthato is talking about lighting the spark. I'm going to go back to grade 4 and light my own spark. Thank you for joining us.